So for this one, I'm given a graph of a function f. So then it says, suppose f is a function and g is f of x 1 minus x over x. So let's look at g prime of x. I'll have to compute g prime using the quotient rule. So it'll be low times the derivative of the high, so that'll be f prime of 1 minus x times the derivative of the inside, which is negative 1. Low d high minus high f of 1 minus x d low, the derivative of x is just 1, over the denominator squared. So g prime of 2 is going to be 2 times f prime of 1 minus 2. So f prime of negative 1 times negative 1 minus f of 1 minus 2, so negative 1 times 1 over 2 squared, which is 4. Okay, so what is f prime of negative 1? And what is f of negative 1? I want to use those two values in my computation here. So at negative 1, the derivative at negative 1 is 0. And f of negative 1 is 4. So I'll put those into my computations here. So I'll have 2 times 0 times negative 1 minus 4 times 1 over 4. So I'll get negative 4 over 4, which is negative 1. On part B, it says let a of x be the integral from 1 to x of f of t dt. So I'm going to look at the graph of f above. So a of 3 is the integral from 1 to 3 of f of t dt. And so if I want to compute the integral from 1 to 3, so that's going to be this area here. And it looks like this is a triangle. So it's going to be 1/2 times the base of the triangle, which is 2, times the height of the triangle, which is negative 4. So 1/2 times 2 times negative 4 gives me negative 4. What about a prime of 5? So to compute a prime of 5, I need to think about a prime of x. So a prime of x is the derivative with respect to x of the integral from 1 to x of f of t dt. And so by the fundamental theorem of calculus part 2, this is equal to f of x. So a prime of 5 is equal to f of 5, which is equal to f of 5 is equal to 2. And what about a double prime? So a double prime of x is going to be equal to f prime of x. So a double prime at negative 4 is going to be the slope of the function at negative 4. So the slope of that function. And so I can just compute the slope by saying, let's see, I can go from this point to this point. So the rise is 3 and the run is negative 4. So 3 over negative 4 is my derivative there. The next one, compute the following derivatives. Do not simplify. So remember, as I'm looking at 5a, that pi is just a constant. And so pi to the x is an exponential function. So the derivative of pi to the x is going to be pi to the x times the natural log of pi, plus x to the pi is just a power function. So it's going to be pi x to the pi minus 1. If h of theta is equal to secant theta, I want to find the second derivative. So h prime of theta, the derivative of secant, is secant theta tangent theta. And h double prime, I'm going to use the product rule here to compute this. So the derivative of secant is secant theta tangent theta. And I'm going to multiply by just tangent theta, plus, then I'll leave the secant theta alone, and then the derivative of tangent theta is secant squared theta. So I'm going to get secant theta tangent squared theta plus secant cubed theta. So that's the second derivative. On the fourth one, I want to evaluate this integral. So the integral of 3e to the x is just going to be 3e to the x. Plus, I want to do the integral of sine of x is going to be negative cosine of x. So it's actually going to end up being minus 2 cosine x. And then plus c, because I don't have a definite integral. So anytime you have an indefinite integral, you'll need to make sure you have that plus c. Okay, for this one, I want to integrate from -3 to 1. So let's see. When I see this, I'm thinking I need to do a u substitution. So let's let u equal x squared plus 1. Then our du is 2x dx. And so what I noticed there is that I have a 2x and a dx here and here. I just need to kind of move them closer to one another. And then the values, the -3 and the 1 are x values. So when x equal -3, u is equal to -3 squared plus 1. So that's 9 plus 1 is 10. And when x equal 1, u is equal to 1 squared plus 1, which is 2. So if I want to change everything over to u values, first I'll just rewrite this as x squared plus 1 to the 1/2 times 2x dx. So now let's convert everything over to u values. So I saw before that when u was -3, when x is -3, u is 10. And when x is 1, u is 2. So my bounds are now u values. And then I have u to the 1/2, and then 2x dx I can replace with du. And so now everything is in terms of u. So I can just go ahead and evaluate this integral. So if I have u to the 1/2 and I take the integral of that, it's going to be u to the 3/2 times 2/3. And I want to evaluate that from 10 to 2. So if I plug in 2 there, I'll have 2 times 2 to the 3/2 over 3 minus 2 times 10 to the 3/2 over 3. And we can just leave it like that.